Hey, math students, Mr. Zacek here. Just got a little bit of tunes here as we get started. We're going to be looking today at trigonometric functions, finding the missing side. But probably should push pause on that as we get going here. Um, we want to use trigonometry to find the missing side and round to the nearest integer. So what we got to be thinking about here is when we're thinking about trig functions, we're thinking about a couple things. We're thinking about, well, we need to have a right triangle. Right triangle with a right angle. And, whatever our device is for remembering that. Okay, is it Tom's old aunt? Sat on her cat and a lot, or Sokotoa, or whatever one of those devices that we have. But so let's just kind of get into it. I think as we get going, you'll pick this up here. What we want to notice here in number one is, well, we've got this angle given that's 39 degrees. Now we know the other one's 90. And we could go ahead and find the third angle. We'd add 90, 139 together, subtract that sum from 180, and we'd be all set. But we don't need to do that. Let's start with identifying what sides we have here. Across from the right angle, that's our hypotenuse. Remember, our angle touches the hypotenuse always and the adjacent. And then across from the angle is the opposite side. So what we're looking for here, in this case, we're looking for the opposite. We know the hypotenuse. So I want to look at my functions. Which one does that represent? Well, that's sine. So I'm going to write, now it's a little different here today. It's the sine of 39. Remember, sin, it's not the sin of 39. It's the sine of 39 equals the opposite, which is x, over the hypotenuse, which is 18. Now, if we think of the sine of 39 as over 1, we can do a little cross product property here, and we get 1 times x is x equals 18 times the sine of 39. Now, at that point, it becomes a calculator function. But what do we want to remember about our calculator? Well, we talked about that yesterday. We want to remember our mode has got to be in degrees. And so again, I wish I could show you that calculator. I don't have that set up right now. But we check our mode, we make sure it's in degrees, and we do 18 times the sine of 39. So x is 11.3277. It says round it to the nearest integer, so that is going to be approximately 11. X represents 11. Okay? So let's do a couple more here. Let's look at number 2. And what do we have? Well, we have an angle, 75. Again, I could find the other one. I don't need to. I want to start by identifying what sides do I have. Well, I've got my hypotenuse, and I've got the adjacent. And let's just go ahead and recognize that this other side is the opposite because it's across from the angle. Remember, opposite and adjacent depend on which angle. The hypotenuse is always going to stay the same. Well, what side are we looking for? We're looking for the adjacent. We're looking for hypotenuse. I see back in my thing on the left here, that's cosine. So, cat and hollered. I might just write that abbreviation out just to help me with it. So I've got the cosine of the angle, which is 75. So when you write cosine, sine, or tangent, it always needs to have something after it, whether that's a variable or whether, in this case, it's the actual degree angle. It's always of something. So the cosine of 75 is the adjacent, which is x, over the hypotenuse, which is 12. So here again, it's set up nicely. The cross product property, 12 times the cosine of 75. Now remember, when you're multiplying, order is not important. I just write the 12 in front of it because it's easier. It doesn't confuse it with that 75. So on our calculator, whatever calculator you have, you're going to get x equals 3.1058, and to the nearest integer is 3. So it's approximately 3. All right, we got one more here, and add a new color in the mix, black. I guess black is maybe the absence of color, but 65. Let's figure out our sides. We've got here our hypotenuse across from the right angle. The other side that that arc is going to touch will be your adjacent, and opposite the angle here we've got opposite. So based off of our angle 65, I can see I've got the opposite and adjacent, okay? And I know that's going to be tangent, opposite over adjacent. So I'm going to write it out. The tangent of something, right? That something is 65. The tangent of 65 is the opposite, which is x, over the adjacent, which is 16. Cross product, x equals 16 times the tangent of 65. I don't know why I used a capital T there. This is the lowercase. And so 16 times the tangent of 65 is going to be 34.31, etc. We're rounding it to the nearest integer, and we have 34. Okay, so those first three represent the simplest ones that we can, because it's, when you do your cross product in each one of them, you're just multiplying them together. So it's very straightforward. We identify it, we set up what the ratio is, and then there we go. It's real simple. In the next one, we're going to have a little bit of different kind of algebra process that we have to do here. So here again, I see that I have a right triangle, I've got an angle, and I've got a side. I'm thinking this is right triangle trigonometry. So I'm going to start off, and I'm going to identify my angle, and I'm going to go, okay, that's my hypotenuse. The other side that the angle touches is the adjacent, and here's my opposite side. Okay, that's across from the angle. So I might go ahead and redo it again. Tom's old aunt sat on her cat, and oh Lord, I have no idea who came up with that. But maybe I should make up my own, but why reinvent the wheel? So what are we looking for? Well, it's adjacent and hypotenuse. So that's going to be C. C represents cosine. So the cosine of 53 is 30 over y. Now, some of you can see what I mean here by this is going to be a little bit more involved. So what happens is when we cross multiply now, or use our cross products, what we get is y times the cosine of 53 equals 30. Now, you can think of the cosine of 53 as a number. It is something. If you put it into your calculator, you would get something. It represents something. So really that's y times a number. Well, I just want to know what y is. So how do we get y by itself? Well, inverse operations. They're connected by multiplication, so we're going to divide. Whatever you do to one side, do to the other. That's right. So these cancel each other out. I'm just going to write it up here. So now y is going to equal, and now I just do that on my calculator, 30 divided by the cosine of 53, and we get 49.849. Okay, nearest tenths place, that's here 8. What's to the right of 8? A 4. So I'm going to keep that as 49.8. 4 stays the same. Okay, so you see we just had a couple extra steps there in our algebra in finding that. I'm going to skip number 5 and do number 6. Both of them have kind of a similar approach to it here. But what do we see here in number 6 is here's my angle. Again, right triangle, so I'm thinking right triangle, thinking Pythagorean theorem, trig. Trig is what we're doing right now. So I got hypotenuse, I got my adjacent side, that's the other one it touches, and then I got my opposite. Okay? Well, what do I know? What am I looking for? Looking for the opposite, know the hypotenuse. So that tells me set on her sine. Okay? So the sine of 52 equals opposite 24 over x. Now, here it is, we go again. We're going to do our cross product. So x times the sine of 52 equals 24. They're connected by multiplication. To undo it, we do division. Whatever you do to one side, do to the other. Okay? So, grab your calculator. 24 divided by the sine of 52, and we get 30.456, and rounded to the nearest tenth, that 5 is going to bump that 4 up to a 5. And, that value better be bigger than 24 because the hypotenuse is the longest side. All right, so 4 and 6, that's the ones that can be a little tricky. You got to pay attention. There's an extra step, and you're going to have to divide. Whereas, 1, 2, and 3, that's really straightforward. You just cross multiply, cross product property, and you're good to go. Okay, now let's look at this because we have a lot of these word problem scenarios that we can use trig to help us find. So here it is. We have a boy. He flies a kite whose string forms a 30-degree angle with the ground. If the boy's string is 15 feet long, how high is the kite flying? All right, so we want to draw a picture, and here's what we got going on. We got the ground, we got a kite string, the kite's at the end, and we have the height. Now, what do we know about that? Well, here's the thing. You know that the height is perpendicular to the ground. So, we have a right angle. If I was a better artist, maybe I would draw like a little kitey. Here's our little boy, okay? And there we go. All right. Now, the string forms an angle with the ground. So, here's our string. It forms a 30-degree angle with the ground. So there's your 30-degree angle. The boy's string is 15 feet long. That's the string. How high is the kite flying? X. Now, it's not going to be super high because the string isn't that long. It definitely can't be higher than 15 feet. Well, what do we got? We got a right triangle. We know an angle. We know a side. We're trying to find another side. We're setting ourselves up for some trigonometry. So we're going to use the hypotenuse here. My other side my angle touches is the adjacent side. The remaining one is the opposite, or across from the angle. So here I am again, new space. I'm just going to say Tom's old aunt sat on her cat or cactus, and oh Lord. All right. Well, I know the angle. I'm looking for the opposite. I know the hypotenuse. That tells me we're in sine. So, set it up. The sine of 30 is, what is sine? Opposite over hypotenuse. The opposite is represented by x. The hypotenuse is 15. Oh, we like these ones. They're set up nice. So we use our cross products. We get x equals 15 times the sine of 30, making sure that we're in the right mode, but we can just go ahead and punch this in, and we get 7.5 feet. Okay. Let's go fly a kite up where the air is bright. He's going to need a longer string if that boy's going to get that kite up where the air is bright. Okay, let's try a few more here. Um, Now, 8, 9, and 10, I'm not going to do those. It's all the same process, and I think we've done enough where you see where those are. If you want to go ahead and try those out, I can check those answers with you in class. Let's do just a couple more of these um, kind of word problems because that sometimes can be a little confusing to us. All right, 11. A straight road to the top of the hill is 25,000 meters long and makes an angle of 12 degrees with the horizontal. Okay, so, excuse me. So we have a ground and we have this road. Now the road is going up. All right, it's really not, 12 degrees is not that steep of an angle. All right, it's going up a hill, and the hill has a certain height to it. So we want to recognize that this is a right triangle setup. All right. The road is 2,500 meters. And it makes this angle, that angle down there, which is hard for me to fit in there, is 12 degrees. So what I want to see, where's my hypotenuse? Here it is. Hypotenuse. The other side it touches is the adjacent. This is our opposite. What are we looking for? Find to the nearest 100 meters the height of the hill. That's x right there. So what do we got happening? New question, new space. Tom's old aunt sat on her cat and hollered. Okay, so we have an angle. We're looking for the opposite. We know the hypotenuse. Here it is again, sine. So the sine of 12 equals the opposite over the hypotenuse. Following that? Okay. Now, cross products, x equals 2,500 times the sine of 12. Go ahead, make sure our mode is right. If we haven't done anything since the last time, it'll stay in the same place. And we get 519.77. Okay, now, find the nearest 100 meters. Where's the hundreds place? Right there. So, what's to the right of it? 1. Keep the 5 the same. Everything else becomes a 0. Approximately 500 meters. Okay. Now we've got a couple other ones here, 12 and 13. I think I just want to do one of them. Building and ladder, tree, either one. These are very common. Let's do the ladder one. All right. So a ladder is leaning against a wall, makes an angle of 63 degrees with the ground. All right, so let's just flip it around. Here you go. You got a ladder, you got a wall. The ladder and the wall make this angle, 63 degrees with the ground. Now, we always make this assumption that the building is perpendicular. If the ladder is 18 feet long, so this is the ladder, okay, find to the nearest foot the distance the ladder is from the base of the wall. So here's the wall is over here. This is the base down here. There's our x. Right triangle, know a side, know an angle, trig. Hopefully we're getting the hang of this. Let's label them. Hypotenuse, adjacent, opposite. Excuse me. All right, we're looking for the adjacent, and we know the hypotenuse. That's going to be the cosine. Cat and hollered. So the cosine of something, it's always got to be something, is 63 equals the adjacent side, what we're looking for, over the hypotenuse, which we know is 18. Hey, we like these. These are the simple ones. It's just a very cross product. 18 times the cosine of 63. We'll enter that into our calculator. 18 times the cosine of 63 is 8.1718. Okay, it says round it to the nearest foot. It's going to be approximately 8 feet from the base of the wall. The ladder will be. All right, so it's about identifying our side sill, hypotenuse, opposite and adjacent based off of the angle. Remember, opposite and adjacent depend on the angle. And then from there, it's putting them in. Some are a little easier. Some have an extra step, so paying attention to that. And if you want to try those other ones for a little extra practice, they're there to help you. We're going to do some in class, and I'll see you guys soon. All right, goodbye.